Here is a really cool CNC project we can make. It's a lid with a textured box, and a bunch of stuff is going to happen here. I'm going to take the lid off first so we can look at the bottom. Everything is an oval. Now, creating an oval in your shop compared to creating a circle in your shop, a little harder to do. So we're going to use the software to create the oval. We're going to hollow out the inside. We're going to use software to get the exact oval shape of our lid and dome the lid, and then apply a texture to that three-dimensional dome. All of this will be laid out on our software and then run here on this CNC machine. Here's a complete list of everything you're going to learn on this video. We're going to do our programming, our layout on a piece of software called MeCar. And what's cool is that many of these CNC machines use MeCar for the design component, and then you just change what's called the post processor when you send it to your machine. So if you want to make a lidded box like I'm going to make now, you can follow along click by click on your computer and do the layout. So here's where we get started on this. First thing, like a lot of software items, we're going to create a new file. So that's over here on the left side, one of my menu items. When I do this, it gives me the opportunity here on the left to choose the dimensions of my material. So we got to know that coming in. In my case, the width is 11 and the height is 6.5. Now what does that mean? The width is my x-axis, the height is my y-axis. So it's a little backwards from the board that we're working with. The way that we're going to put the board on the machine is the length of my board is 11, the width of my board is 6.5. Now it's also important to come down here and enter the thickness of your material, because when we make our lid, we're going to cut all the way through it. And the machine's going to need to know exactly how thick it is. So this, you would literally do your best work by measuring the thickness with digital calipers. If it's 1.1, enter 1.1. Don't do rounding here. Tell the machine exactly how thick it is. That gives us a good starting point. The other thing we need to know is this XY datum. This is, if you think back to your high school or middle school math, this is the origin of the product. Where's the X going to zero and the Y going to zero? And for this project, I'm going to choose the center of the piece. Sometimes you might choose lower left, like a real typical graph, X, Y, or center, or one of these other spots. But for this project, we're going to work off the center. What we're looking at now, this big piece of paper, this is the side, this is my project, this is my board, and here in the middle, 0 and 0, this is the center. We're going to create an oval-shaped lid. So let's take advantage of what the software is capable of and create an oval. So I've come over here to the menu, draw ellipse, and we can do this a couple different ways. I can come over onto my board and manually draw the ellipse, or I can enter in dimensions that will work for this project. So with x-axis of 8, that's actually a pretty good number for what we're doing here, and a height, y-axis of 4.75, that's going to work pretty well. And then we can create. Now, if for some reason you're not feeling the love on that, you wish you'd gone a little bit bigger or smaller, we can always click it and we can drag it to be bigger, drag it to be smaller, or change our minds altogether and delete. Then let's come back again, create that oval again. The other thing we can control here is where it's centered. So much like when I started with the project, we can pick the spot that we want to be the 0, 0. So I can go to that lower left point or center. For this, it's going to work easiest if we stick with the center of the board being our layout point of 0, 0. Same for the ellipse. So let's go ahead and create that again. Now this is our lid. So what we want to do next is get the dome shape going. And I'm going to come down here to the bottom of my menu and clip art. And this is really cool. There's a lot of stuff in the can here that we can work with. We're going to go to domes. And what happens here, these domes are set up for different thicknesses of material. We're going to use this one, the leftmost dome. Click, hold your button, and just drag that into your workspace. Now that's a little weird. Oh, we have a big circle instead of the oval that we want, but we can change that. We can control that. So I'm going to go back to my drawing down here on the left. And one of my options is to control the size of my object. So right here, selected object size. And I'm going to tell that how big I want it to be. Now if we're smart, we'll remember the dimensions that we used on our oval, and that is 8. And I'm going to unlink the X and Y. And this is 4.75. So unlink X and Y, what that would do is it would keep the two proportional. So if I change this to 8, it'll change this accordingly. In this case, I don't want to do that because I'm creating a custom oval, a custom shape to my particular workspace. Now let's go back and do this again because I put the number in the wrong spot. That looks better. Now we want this to remain centered in our workpiece. So one way we could do that would be to click it, see how the squares come up around it. Then we can drag it wherever we want it. But let's let the software do some of this work for us. If we come back here and look in our menu, we have an option to align objects. This one centers whatever you've just highlighted completely in your material. So let's click that one, and it puts that oval right smack in the center. Now, when we look at this, my dome is not quite the same size as my oval here. And the reason, even though we manually entered numbers in, is the software changed this dome just a little bit. This is what's called a pixelated form. My oval up here is a vector form. So they don't quite play nice together, but they're going to play nice enough together that things are going to work out just fine. So I'm going to pull this a little bit higher until it gets to my oval there. And I'm going to pull this a little bit lower till it gets to my oval there. And that's going to work out just fine. Now I've got my dome in here, and I've got this oval, which is going to help define the exterior of the dome. But one of the things, and I can show you on the real cut, is that what we need to do is create another oval outside the oval of our lid, of our dome. The reason for that is that when our V cutter comes through here, if we don't create this extra step, this extra area of clearance, this cutter, the V cutter, is going to hit the wood. So we have to add another oval just for the sake of clearing out a little bit more material so there's clearance for the router bit and the collet on the router. Now this is pretty easy to do. One way we could do it would be we can click this, copy it, paste it, drag it larger. But again, let's let the software do what the software is good at. I've clicked that oval, so it's pink now. Come down here to Offset and Layout. And I'm just going to create an offset. This is going to work out just fine. I'm going to do a offset outwards. And let's go a little bigger than this. Let's go 0.625. That's 5/8 of an inch. And now watch what happens when I click on offset. Bang, it automatically creates another oval for me. Now we're to the fun part. We get to actually go to Toolpaths. Close out of this. And I clicked off my work so that that pink would go away. I want to click my big oval, and I want to click the dome. While I'm doing the dome, while I'm clicking the dome, I'm holding the Shift key. That means now I've got 2 items selected. Holding the Shift key lets me pick 2 items. The oval here that defines the perimeter of the dome is not selected. Toolpaths is real convenient. If you hit the pin up here, that's going to keep that toolpath menu open instead of having it toggle back and forth between open and closed. Then we're going to come down here and use the 3D roughing. So like you often would in woodworking, we can do a roughing and a finishing pass. The roughing is just like it sounds, like it's going to quickly take a lot of material off, not leave a real great surface finish. Then we'll come back and we'll finish this. So let's go to 3D roughing. And up here on our tool menu, we can choose from a variety of tools. End mill, that's what we're calling a typical straight router bit or spiral router bit of different diameters. If you have a real small area to excavate, use a small cutter because it's got to be able to fit in there. If you have a large area to excavate, go to a bigger diameter cutter. For where we're at here, this 0.375, that's 3/8 inch, is going to work just fine. And we have an option here of where we want our excavating, where we want our material removal to end. Model boundary would be the end of our dome, but we don't want that. Remember, we want to go to that outer oval so that we get this extra area cleaned out. So we go to selected vector. And here in the title, I'm going to change the name of this file because I want it to be more descriptive. When I get to the machine, I want the file title to help me. I want it to tell me what bit I'm supposed to be using and what I'm doing. So I'm going to call that 3/8, 375, roughing. Now this is pretty cool. Let's calculate. This is the tool path we're looking at. What's really cool to check your work is let's use this part of the menu, preview tool path. That's our router bit. Excavating, excavating, excavating. This is going to give you a visual idea of, did we do this right or not? Now this is looking at it from the top down. Let's grab it and turn it. This is the roughing pass. See how it's left these steps kind of like a pyramid? It created that extra flat at the bottom where we're creating clearance for our V cutter. So this looks good so far. Now, on our dome, what we want to do is finish the dome, but we don't need to do finishing out here in that flat. So we're going to pick the dome, come back to our finishing pass. Let's finish that dome off. What we need to do here is check our cutter. Now in this case, generally for this 3D finishing, you're not going to use a bit that's straight on the bottom. You want to use one that's round on the bottom. That's all of our ball nose cutters here. And again, pick the size of the cutter depending on the size of the work you're doing. So we're going to go with a 1/2 inch, a 0.5. Whoops. There we go. And I'm going to change my title, 0.5 finish. Lots of information here. And what I'm trying to do is give you an overview. In future videos, we can drill down further and further with where this can help us. But we're going to get you quickly here to a point of success. So I'm going to calculate. Preview toolpath. Zip, zip, zip. Have a look, see what we've got. There's our dome. Isn't that cool? How that lets you see what you've got. Now, we have a texture on our dome. There's our dome. And we're going to pick this outer oval as well. So I'm shift. Now that outer oval is pink and our dome is selected. And one of our options right here is texturing. Click on texturing, and once again, we can pick our bit. So here in select, texturing is pretty cool. You got to try different cutters just to see what they look like. Straight bits, ball nose, V bits. We're going to use this 90-degree V bit to do our texturing. And then lots of options that you can play with here, and it changes the parameters, it changes the randomness. We can also change the angle at which we put the texture on. This is something you need to just experiment with and see how it goes. One of the things that's really important here is we need to project this onto the 3D model. We have to tell the computer that we don't want it to just texture straight across a flat surface. We want it to go down onto that dome. Now again, our name for the file, 90 degree, and it's texture. Again, this is our toolpath, those lines. Let's preview our toolpath. Once we're that far, we can rotate. How does that look? If you don't like how it looks, we can undo. We could go back and change those parameters, run it again. Let's leave that on there because I'm feeling the love on that. I like it. The only thing we need to do now is cut our lid out because we don't want to leave it attached to that big board. We want to separate it. Come back to our drawing. Now in this case, what we want, remember the really big oval, that was just to create that extra area of excavation. The little oval is what defines the outside of our lid. Click on that. Come back to our toolpaths. And this one is called our profile toolpath. And that's going to cut around the perimeter. Once again, what a surprise. We can choose what cutter we choose to use. Now, for convenience, I'm going to go with the same bit that I did my excavating on the 3D work with, and you'll see where that pays off in just a sec. So 3/8 diameter cutter. And then as we look at our parameters here, we can do all sorts of stuff. We can cut outside the line. We can cut inside the line. We can cut on the line. We don't want the bit to straddle the line. That's what this would do. And we don't want to go inside. That would make the lid smaller. We want to be on the outside. Now think about your woodworking. Is it easier to ease into your work or plunge and cut? It's easier to ease in. So let's put ramps into the work, and that's going to help the cutter ramp in more gently when it first starts to cut. Now as we cut, one of the things we don't want to do is just plain cut through, because then the lid would fall away from the rest of the material. We're going to leave what are called tabs. That's going to hold that in place. Tabs are here on the menu. We're going to add tabs. And once we add them here, we can change the distance between them. We can change the number that we're using. And what's also cool, if you look at the drawing itself, is that, let's say for a particular piece, you didn't think that that was a good location for the tab because maybe you don't like that it's right there on the end grain. We can drag it to another spot, and we could change the locations of our tabs, the numbers of our tabs, the dimensions of our tabs, whatever you need to do in order to get this to work for the project that you've got cooking. Now this, it's again a .375 cutter, and this is our exterior. It's going to separate the lid from the body of the material. Now I can see from looking at this I made a mistake, so let's go back, and what I'm looking at here is I don't think I set deeply enough on that cut. So let's go ahead and preview it, and I will tell if I'm right or not. Yep, so it's not shallow. I mean, it's not deep enough. It's too shallow. It's not cut through. So I'm going to undo, and benefit of being on a computer, double click this piece, and here's the problem. Our cut depth, 0.63. That's a little over ½ inch. Our material's an inch thick. So the bit wasn't told to cut all the way through. Now, one of the things that is going to make this machine a little bit faster is, remember, we're actually have a lot of that material already excavated away. How much do we already have excavated away? Well, let's close this and look at our material setup. The gap below our model is 0.4 inches, just under ½ inch. So that tells us how much wood is already gone from above that point, about 0.6. Okay, keep that information in your head. Let's go back to this cut. For a starting depth then, instead of 0, that's the top of the board, let's come down a little bit. Let's come down to 0.375. We want to cut all the way through. So from that point, we have to continue. That's 3/8 of an inch. We got to go another 5/8 of an inch, which would be 0.625. But we need to cut all the way through. So let's go a little bit beyond that, 0.64, and calculate. and preview all toolpaths. All right, so let's figure out what's cooking with our final cut through here. Oh, cut depth of 0. I must have clicked in the wrong spot here. 0.6, what did we say? 0.64 to make sure we were going to go all the way through. All right, this is good because we're getting a warning saying you're about to cut through your material. This is to help protect you in case that wasn't your intention. How far are we going through? Are we going to cut too deeply into the bed of the machine, the spoil board, whatever's going on? So this is fine. This is what we want to do. We want to separate that lid. So that's a good warning, but doesn't bother us at this point. Let's go back and preview this toolpath. Now we're cooking. All right, it cut all the way through. It left our tabs. This takes care of our lid. Good news, the hardest work is done. The base is a whole lot easier to lay out. So we're going to come back, create a new file, and work on the base. Before we exit the lid file, let's take advantage of some information here. First, let's look at transferring what we know here to what we're going to do on the base. Bottom line is the outside dimensions of the base are exactly the same as the outside dimensions of the lid. That's defined by this oval right there that's now pink. So let's take advantage of what computers do for us and let's copy. I'm going to Control C. I'm copying that element and we're going to use it again in just a little bit. Before we leave here, let's get our tool paths exported here because from here we got to get them out to the machine. We got to get them to the shop bot in order to run them. So first thing I'm going to do is move my 3/8 exterior cut up, and you'll see why in just a second. I'm going to click the roughing cut, click the exterior cut. This thing that looks like an old-fashioned floppy disk is my save. Choosing my post processor here. Remember I said same software for a lot of these machines, but you got to use a post processor that works with your machine. I'm going to output these to one file. So what's cool about this, remember I said there's kind of an economy of movement that'll come from using the same bit. So by choosing these and putting them in the same file, it's going to run those two files back to back for me. Save toolpath. I'm on a removable disk, a flash drive here. I like to create a folder just to help keep things organized. So this is our lidded box lid. And within that, we're ready to save that file. Then we're going to have our finishing cut. Oops, because I forgot to click it here. There we go. Now we have our finishing cut. And then our texturing cut. Now everything for the lid is on the flash drive. File, new. Let's save these. Now by default, what's going to happen when we create our new file, if you look over here on the left side, is it's picking up the same material dimensions from the last project that we entered. All of this is fine. Our material width and length are the same, but our thickness is different. The base of our, or the thickness of our base is 1 1/4 instead of 1. Everything else is just fine. We're still going to use the center of our material as our origin. Once again, we've got a big workpiece here. Now don't create an oval, just paste an oval. So isn't that cool? We pulled that from the old file into this one. This then is the outside of our box. Now when I rabbet the lid, I want to use a 1/4 inch rabbeting bit. So that means this is the outside. I want to create an inside that's a 1/4 inch away. Let's let the computer do what it does. So I'm going to come down here to my offset. Remember, we used this before. And in this case, I want to go in. I want to go in toward the center. So I'm going to go inwards. And if I use a 1/4 inch rabbiting bit, I should make my wall thickness a little less than that so that the parts aren't so tight that they won't close. So let's go 0.24, 0.25 would be a 1/4, and create an offset. There's the inside of my box. Pretty cool. Now, with just that little bit of work, we're already ready for our toolpath. So choose the inside, toolpaths, and this we're going to, let me pin it so it stays open for us. There we go. We're going to pocket this out. So pocket cut. Now, once again, we can choose what kind of cutter we want to use. It's got a lot of material to take out. Use a big cutter. I'm going to go with our 1/2 inch bit. And then here we can set the depth of cut. So let's think about this. Got an 1 1/4 box. This is currently set for an 1 1/8 depth of cut. That's going to work out just fine. Working my way down here. This is a good thing to look at, this raster option would move the bit back and forth in the same direction as the grain of the material. Maybe it give you a little bit better surface finish. This is going to move just like the lines on here show it. That's going to take material out a little bit more quickly. I'm going to go with the more quick material removal. We can ramp our bit into the work, just like we talked about before. That'll give it a more gentle entry. And then let's call this what it is. 0.5 is our bit size. And we're doing the interior of our box. And then calculate and see how that comes out. Preview our toolpath. See how she looks? There, we've hollowed that piece out. Now we'll come back to our drawing, pick the outside of the box. And you've already seen this. We're going to do a profile cut. Now, smart money, pick the same bit so we don't have to change cutters and we can run one file right after the other. So I'm going to go with my 1/2 inch bit, just like I used on the inside. We want to cut all the way through so that we can separate the body of the box from the material. So we're 1.25 material. Let's go 1.3. So we cut all the way through. And add tabs, because again, we don't want it to just fall out of there. So if we add tabs, there they are. And then again, we'll ramp our moves so it eases into the cut. This then is a 0.5 exterior. Calculate. And there's our warning again. We're going to cut all the way through. Well, that's okay. We want to cut all the way through. Preview our path. Now, here's a good thing to look at before we save this and go run this. Let's go back and look at our exterior. Think about this. This is a pretty significant cut. So we can come up here and look at how many passes are we doing this in. Let's edit those passes. This shows us, here's the thickness of our material. We're currently doing this in 4 passes of almost 3/8 of an inch each. 375 would be 3/8 of an inch. That sounds kind of aggressive to me. So I'm going to come down to the bottom and I'm going to increase my number of passes so that it's easier on the cutter, easier on the machine. It's going to do the work a little slower, but I'm going to get a better result. Then calculate. So even though we changed it there, nothing changes in the software until we come back down and calculate. We get the warning again. So all it did there is it increased the number of passes. Let's do the same thing on our interior just to double check. 9 passes, well that's a lot. We don't need to go quite that many. We're taking off about 1/8 per. Let's reduce that to 7 just like we did on the outside. Calculate. We're good to go. I'm going to save these. We're using the same bit on both of them. Now here's a really important aspect. The machine is going to cut our part in the order in which these are listed. You want to do the heavier pass before you do the lighter pass. That means these are sitting here in the right order. If they're not, you can switch them like I just did. You can drag them so that they're in a different order. So I want to get the interior excavated before it defaults to the outside. Output to one file. We have the right post processor for our machine. I'm going to go back. That's the lidded box lid. I'm going to create a new folder so I don't mix them up. And again, even though this only says interior, remember that both of those cuts are captured in that file. That takes care of our work here at VCarve. Here's the cool part. We're going to go fire up a machine. Now we're ready to bring the work that we designed out here to the machine itself and do some cutting. I've got my blank for the lid on the machine. We're going to use walnut. It's currently not secured. So a couple of jargon things here. This piece of MDF, that's my spoil board. You can probably see from other areas on here, it's already been cut into. That's just fine. What we need to do is get this so it's going to stay in place. Here's a great way to do this, hot glue. Now what I do not want to do is just simply put dabs of hot glue on the bottom and set this down, because if I don't get it perfectly mated to the spoil board, I might have high spots and low spots where this is a little bit canted. What works out nice instead is to use the hot glue kind of like a caulk gun, and I'm unplugging it just to give me some mobility here, and I'm going to run a bead of hot glue on the inside corner here. Same thing on this edge, the far end, and the back edge. Give that a chance to cure, to cool. And that's plenty secure for our work. And remember that we're cutting through. We created tabs for that. So that's just fine. The perimeter is going to stay in place. The lid will be tabbed to the perimeter. I've already installed bit number 1. We're starting with a 3/8 diameter cutter. So I've got that bit in the spindle. You're going to see bit changes as we go here. Installation is just like you would do with a router. But what I need to do now is tell the machine where this piece is. And remember in our layout, we decided that the center of the board would be what we're going to call the origin, the 0, 0 of our work. I mark that out. So now I'm going to open up the right part of my software for the ShopBot. And that's going to let me jog the head whatever direction I need to in order to get it in the right spot so that we can get it over that X. I can move X and Y. I can also move Z to get it a little closer to the work to make it easier to tell. Now we've got a little wiggle room around the outside of our material between the edge of the lid and the perimeter that we've created. So if you miss by a 1/16 or probably even 1/8 of an inch in this case, it's not going to be a huge deal. But now we need to tell the machine that's where we are. The option then here on my menu is 0 axes. And I'm going to tell it that's my X0 and that's my Y0. That's not my Z0. What do we do then about Z? I'm going to raise my head just a little bit. And for Z, we're going to use what's called a touch plate. This is the touch plate. And it's connected electrically to the machine. It goes in between the cutter and the work, and the machine knows how thick that touch plate is. It's pretty cool stuff here. So I'm going to tell the software to 0 the Z axis. That's this option right here on the menu. It's going to ask me Is the touch plate in place? Yes. Makes a cool sound. So now the machine and the software know that the top of that work, that's my 0 point. At this point, we're good to go. We're going to cut apart. We're going to find that file. It's on the flash drive that we brought from the other computer. Lidded box lid, that's what we're working on first. 0.375 roughing. Again, both cuts are in the same file. Start, then it's going to ask me one more time. It's bringing the file in. It's going to ask me to go ahead and start. So here's what's going to happen. First thing I want to do, I'm going to back out of this. Come back to my ability to move the head up and down. That doesn't change where the machine thinks my 0 is, but it buys me some clearance so I can put my dust shroud back on. And remember how we did this. Cut part. There's our file, 375 roughing. That's the bit that's in there right now. Open. Start. Here comes OK. When I click OK, the spindle's going to start running, and the software and the machine are going to take over from here. So what we were seeing right at the end there, when the spindle was moving up and down, it was leaving the tabs behind. It was cutting the perimeter, lifting, leaving the tab, cutting the perimeter. Next thing we need to do is change cutters. I told you we were going to get to see some of that. I'm going to turn the spindle itself off. It is a router, so we want to make sure that there's no chance of power going to it. I'm going to increase my Z just a little bit so it's easier to get to. Pop this bit out, get the right collet, because we're going to a smaller shank, and get our new bit in. Quarter-inch collet, just like a standard router. Our round ball cutter, very similar. It really is. It's a core box bit that's doing this work for us here. Let's think about what we got going here. We have an X and Y 0, and we have a Z 0. Nothing we've done has changed our X and Y 0. That's still the same. It's over that mark that we created. But we've changed our Z because maybe this bit is sticking out further or less far than the bit we had in previously. So I'm going to bring my bit a little bit closer. And then once again, use our touch plate. It is important that the touch plate is on our original 0 surface. That's the top of the wood, not down here on one of these lower tiers. And then 0 RZ. Raise everything up so I can get my dust shroud back on, and we're ready for our next cut. here on my software, cut part, find it. It's the 0.5, it's the 1/2 inch finishing cut. Remember to turn your spindle back on, then we can hit OK and we're going to run. That's pretty cool. Now, surface finish that we achieved off that ball, I'm not too worried about it because we're going to come back and we're going to texture that whole thing. So we can control that. Remember I said about the software that there's all sorts of different stuff that you can do. We're just trying to give you a preliminary at this point. Spindle is shut off. We're done with this bit. Going to go back to a 1/2 inch shank cutter, so change collets. And you know where we're going next. We're going to check our Z. We're going to touch off the touch plate again. We're going to bring up this particular file, and we're going to do our texturing. Now, I can't go here for my Z anymore because I've lowered this beyond the original 0 point. So we got to get back over here to where wood is as yet uncut. About there. Get a little closer to our work. Get back up so I have a dust shroud. Spindle back on, press the go button. And again, as I go now to cut apart, find that file, 90-degree texture, helps me keep things straight. Start, and OK. Pretty cool. Let's get that head out of the way. And there is the textured lid for our box. Now, with our hot glue, what you can do is use a utility knife and slice. Work your way around all 4 corners. Don't try to just pull it up because you'll take a lot of MDF with it. That's pretty nice looking, beautiful piece of wood with the grain and the texture. Really looks cool. Now with the wood with the hot glue on it, that doesn't bother me because this whole frame is going to come off of there. With the MDF, use a sharp chisel, and if you have any excess, you can slice that off the surface. Now these are called spoil boards. Eventually, we're going to get so much junk and so many cuts on here that we do what's called fly cutting, and we resurface this whole board so that little bit of glue doesn't bother me. Here's what I'm going to do. We still have to cut our base. So I'm going to get the base hot glued in place. I'm going to recenter. I got to change my cutters. We're going to do that base with a 1/2 inch bit. I'll take care of all that work. Then when you come back, we'll be ready to run. New board in place, 1¼ inch thick. I zeroed my X and my Y over that mark. I then also zeroed my Z down to the surface using the touch plate. Next step, call up the right file here. And remember, these files are going to run back to back. because we put them both in the same file. So they're going to run one right after the other. That's the lid again. Let's look here for the bottom. I've already got the spindle turned on, so we're good to go. Let's jog that head out of the way so you can see what we've got. There's the base of our box. I'm going to do the same thing I did before. Use a utility knife to cut that loose of the MDF. And I'm going to do a little bit of bandsaw and router table work, and we'll come back and have a look at our box. Here's our box. Now what I did was, went to the bandsaw and I cut the tabs on the bottom of the box. I left the tabs sticking out a little bit, so I cut them proud on the bandsaw, then go to a sander and sand the tabs off. The lid, then, I took to a router table and with a 1/4-inch rabbiting bit, cut that rabbet. Remember how we programmed this. We have a just under 1/4-inch wall thickness, making those two parts go together. Now, for those of you who are probably going to ask, could we have done this work on the CNC? And the answer is yes. It's just another step in registration, and we want to start with baby steps to get to this point, but yes, we could have done this, created the rabbet, done this, created the dome and the texture. It's all possible on the CNC. So a lot of information here, but watch that programming click by click. You can do that along with us on your computer, and that takes you through the steps that we used to create a textured lidded box.